Hello. Today I want to talk about the information theory, the entropy, chaos divergence, and cross entropy. The first class I want to talk about the entropy. Okay, let's think about two cases. Which case does have more information? First, it's clear today, and in the news, it will be clear tomorrow too. And the second is it's clear today, but in the news it will be heavy rainy tomorrow. In the first case, probability of clear in tomorrow is high because today is clear. Intuitively, we get less information because it's very common. On the contrary, probability of second case is low, but we get information a lot. By this example, we can figure out that probability and information gain, information quantity has inverse proportional relation. Information gain can be thought as alarming late. Most of the days in life, we get alarmed in the event of low probability. For example, if World War III happens, we will be alarmed too much. On the other hand, we gain a lot of data. Basically, an event which happens in low probability makes us alarmed, right? And it has a lot of data. This relation is the main concept of information theory. The main function of information theory is quantifying the information and making possible to calculate it when we can measure its probability. We can formulate above example like this. P tomorrow equal heavy rainy given today equal clear, or P tomorrow equal clear given today equal clear. Okay, we can define how to measure information quantity when knowing the probability of an event. The first formula is about the entropy. H of x equal minus log 2 p of x. The first equation shows the answer. X This x is a random variable. In above example, x is a random variable showing whether of clear or rainy. Let me suppose that x has a specific value. P of x is a probability, and h of x is the information quantity or self information. For example, x has an event E, and its probability is P of E equal 1 divided by 1024. It means that only a time happens during 1024 times. And information quantity is, we can assign this event probability to this formula is minus log 2 1 divided by 1024 is 10 bit. Extreme case is P of E is 100%. In this extreme case, we can only get the information that E always happens. So we don't get any alarming information like um, tomorrow the sun will be sunset, or yes, we can imagine a very common event, yes, and this doesn't alarm us, right? So if we additionally get to know that E happens, if we assign the P of E is 1 into equation for this equation, and information quantity h of x equals 0. We can change base 2 to E natural constant, then unit is changed from bit to nature. Okay? Yes. And what is the entropy? Okay, we mentioned, and entropy is the average of information quantities that random variable x can have. And this formula, the second and third, is the entropy formula. And the second one is the case of discrete, and third one is the continuous case. And the px is the uh, probability of a specific event, and we you can uh, you can find that this px is here and here, and in the next class you will learn the cross entropy and Kale divergency, and another term you will learn another term and it's similar. And now the you just memorize this formula, okay? And we talk about another example of dice. Let me explain entropy with dice. Let random variable x as a spot on a die. It is 2, 2, 6, okay? And x can have a value from 1 to 6. And each has the same probability as 1 uh, divided by 6, it's a very normal case, right? Accordingly, entropy is 2.585 bits by using this formula. And this the dice case is discrete, and we can use the second formula, right? So by assigning the event this uh, equation, and we can get like this. Okay, think about the characteristic of entropy. Entropy is maximized when all events which have the same probability of occurrence. In other words, the extent of chaos become maximized, or we can call it as uncertainty become maximized. In the dice example, we don't know which spot will we get, and predicting it is very hard. On the other hand, the case of minimum entropy is an event has 100% probability, and others have 0% probability. In this case, entropy is zero. In other words, uncertainty is nothing. Accordingly, no chaos, right? How about this example? This die is a special probability of p x equal 1 is 0.5, 1 divided by 2, and other each event has 1 divided by 10. Is this case uncertainty increasing or decreasing comparing to normal die? Okay, Okay, before check it, suppose that there are two cases. Each case has two probability distribution with random variable x. The first one, as above example, two probability distributions are largely overlapped. In other words, there are nothing special difference between two. But in this case, two probability distributions are little overlapped, right? Only here. Accordingly, they are different. Then how can we know the difference as numeric value? Because we need to calculate it. In order to quantify the difference, we do it with KL divergence. The full name is Kullback-Leibler divergence. Okay, next class, we will talk about the KL divergence, and you need to just review the entropy concept, and the formula is here, and you need to study what this formula has meaning. Okay. Okay. See you next class and goodbye.